Okay, so last time around I talked about Charles's law and multi-stage compressors. So here we have a 4-cylinder, 2-stage small industrial compressor that I'm fixing up so I can sandblast. I kind of enjoy working on cars and fixing stuff up. Anyway, so here we have, to your left is a smaller cylinder, and to the right is a large cylinder. The large cylinder is the intake. So here we have intake, air comes in. Here we have a unloading valve. So what that allows the compressor to do is, instead of the electric motor turning off and on to stop compressing air at when it reaches full pressure, it unloads the valves, which is a smidgen more efficient. Okay, so air comes in, gets compressed, comes out right here. Here we have a thin tube. Through that thin tube, it goes in front of the pulley slash fan, comes around to the other side where there's another set of large and small, except on the opposite sides, comes into this small cylinder here, and you see it's still finned. It's finned, and then gets compressed again, and because it's already been compressed once, it's about half the volume that it used to be, and so this area of this cylinder is about half the area of the large cylinder. Okay, so anyway, so it gets compressed again, and it reaches final pressure. Okay, about 100 psi, and then to pull more heat out of it, more heat, because we don't. So the problem is, if the air is hot and you compress it, then it cools later on, you'll lose volume. That's what Charles's law says. So if we can keep the air from heating up, we can do it more efficiently. So the more fins and more intercooling and more stages makes it much more efficient. So that's why most modern compressors actually use screw compressors, which can cool it the whole length of the screw to reduce heating of the air. Now, it gets hot, but the less you heat it and the more you compress it, the better off you are, the more efficient it is. Okay, so anyway, so it comes out of this second cylinder here, comes out, comes around, and get over here so you can see it, is another final radiator where both final stage cylinders dump air in front of the flywheel pulley, and which has fins and fans built into it to suck the air through here, and that cools it again. Okay, so it's got 4 cylinders, big, small, and big, small, that and 2 stages. Okay, so my goal is to get this up and running and do some sandblasting this summer. We'll see. So my other one works okay, so I'll take you over and show you that one. So in the process of cleaning, throwing stuff away, pulling stuff off shelves, I got way too much stuff. Anyway, so here we have a 62 Austin Healey. Here we have 59 Austin Healey. Getting dusty. All right, so here's my compressor. It still runs. I pulled the guard off so we can see it better. Okay, so here we have, this is a 2-stage and 2-cylinder. So here we have the big cylinder, small cylinder. The big cylinder brings in air through the filter, compresses it halfway to final stage pressure, and then it's got 3 tubes and 3 fins down there, you can see, that are in front of the pulley with the blades in it to act sort of as a fan to move air across everything. Okay, comes in to the small cylinder through here and gets compressed to final pressure and goes into the receiver tank. All right, so 2-stage compressor, 2-stage compression. Makes it more efficient. It's based on Charles's law. The other thing is that based on Charles's law, what I would do is, instead of this compressor was in a warm factory, I would instead of compressing warm factory air, I would have the option of pulling in outside air in the wintertime, which would compress even more efficiently. Anyway, so that's my little talk.